Do you ever wonder how this, and this works? It is something that you are familiar with. But before I introduce it to you, let me discuss electrochemistry. Electrochemistry is the branch of chemistry that deals with the inner conversion of electrical energy and chemical energy. Redox reactions are chemical reactions where electrons are transferred from one chemical species to the other. As they do so, their oxidation state changes. A loss of electron by oxidation reaction results in the increase of oxidation state of an atom, making it more positively charged. The lost electron is then transferred to the other chemical species by reduction reaction, causing a decrease in the oxidation state of an atom, making it less positively charged or negative at times. How does electrochemistry relate to the three things that we have shown earlier? Electrochemistry is fundamental in a wide range of important technological applications. For example, all sorts of batteries, from those used to power a flashlight, to a calculator, to an automobile, rely on chemical reactions to generate electricity. Let us now go back to the question earlier on how flashlight, calculator, and automobile works. Yes, you got it right. It works because of battery. On the next video, let us further discuss and deepen our understanding about batteries.
Now that we already have an idea of what an electrochemistry is, we'll now proceed to one of the things it is associated, which is the battery. A little background on batteries. There are two known personalities who are considered to be its creator, namely Alessandro Volta and John Stringfellow. Batteries were first invented by the Italian physicist Alessandro Volta in 1800s. He discovered that certain fluids would generate a continuous flow of electrical power when used as a conductor. This discovery led to the invention of the first voltaic cell, more commonly known as battery. Volta learned further that the voltage would increase when voltaic cells were stacked on top of each other. In 1830s, John Stringfellow, an aircraft designer and photographer, designed and made an early dry cell battery. He had to mix and make up all the chemicals needed for the process in making this kind of battery. As new technology demands safe, lightweight, high-capacity, and rechargeable batteries, American physicist Professor John Goodenough innovated a new form of battery with lithium. Lithium is one of the lightest elements in the periodic table, and it has one of the largest electrochemical potentials, thus produces the highest possible voltages in a compact and lightweight battery. But then, it wasn't stable. Therefore, in the 1990s, by introducing a stable lithium-ion cathode, built on lithium iron and phosphate, Goodenough made another major leap in battery technology. However, if we are going to talk about how electrochemistry was associated with batteries, Michael Faraday is one credited for that. In 1840, the batteries were presented to Faraday, who then pursued the relationship between electricity and magnetism. In the course of his research, he invented the first electric motor and the first dynamo. His chief electrochemical achievement was to show that magnetoelectricity had the same chemical effects as electricity generated in other ways.
Ever wonder how a technology lasts long? It is because of a thing that produces an electric current, which are batteries. But what is a battery, and how does it provide electricity? Named after famous inventors Luigi Galvani and Alessandro Volta, galvanic or voltaic cells are electrochemical cells in which a spontaneous redox reaction takes place generating electric current. Battery is a galvanic cell that has been specifically designed and constructed in a way that best suits its intended use as a source of electrical power for specific applications. It releases electricity through the anode and cathode's chemical reaction. The flow of electrons between these two provides an electric current that can be used as a source of electrical power. These two are parts of batteries which will be discussed later. There are two types of batteries, primary and secondary. Primary batteries are non-rechargeable, disposable, have short shelf life, and its electrochemical reactions are non-reversible. While secondary batteries are rechargeable, have long shelf life, and its electrochemical reactions are reversible. Let us now discuss the several types of batteries that are widely used. First is dry cell. Dry cell is an electrochemical cell that do not have fluid component, and the most common dry cell is Leclanché cell, which are used in flashlights and transistor radios. Next is mercury battery. It is used extensively in medicine and electronic industries and is more expensive than the dry cell. It consists of zinc anode with a strongly alkaline electrolyte containing zinc oxide and mercury oxide. Third is lead storage battery. It is commonly used in automobiles, which consists of 6 identical cells joined in a series. This type of battery is rechargeable in most common storage devices. Lastly, lithium-ion battery is commonly used in cellular phones, tablets, digital cameras, and laptop computers. Though it is not considered as a battery, a fuel cell is a galvanic cell that requires continuous supply of reactants in order for it to function.
Components of batteries. We may wonder, what are the components of a battery we typically know of? What are their uses and significance as a part of the battery? Batteries traditionally comprised of 3 essential components. Number 1. Anode. The anode is the negative or reducing electrode that releases electrons to the external circuit and oxidizes during an electrochemical reaction. In an alkaline battery, the anode is usually made up of zinc powder. It becomes the negative electrode when discharging and becomes the positive electrode while charging. Anode material should exhibit such properties. 3 of those were A. Efficient reducing agent, B. High coulombic output, C. Good conductivity.
Number 2. Cathode. The cathode is a positive or oxidizing electrode that acquires electrons from the external circuit and is reduced during the electrochemical reaction. In an alkaline battery, the cathode is made up of manganese oxide. It is the positive electrode when discharging and becomes the negative electrode when charging. Cathode material should exhibit such properties. 3 of those were A. Efficient oxidizing agent, B. Stable when in contact with electrolyte, C. Useful working voltage. Number 3. Electrolyte. The electrolyte is the medium that provides the ion transport mechanism between the cathode and anode of a cell. It is often thought of as liquids, with dissolved salts, acids, or alkalis that are required for ionic conduction. It should be noted that many batteries, including the conventional AA, AAA, D batteries, contain solid electrolytes that act as ionic conductors at room temperature. The materials used are potassium hydroxide, ammonium chloride, or zinc chloride. Electrolytes should exhibit such properties. 3 of those were A. Strong ionic conductivity, B. No electric conductivity, C. Non-reactivity with electrode materials. Some other parts of the battery are the following. The separator is a fibrous fabric that separates the electrodes. The collector is a pin in the middle of the cell that conducts electricity to the outside circuit. The container serves as the house of the cell's components.
Among numerous types of batteries, they all have one thing in common: susceptibility to corrosion. Corrosion happens with the presence of both oxygen and water. It then accelerated by pH, salts, contact with metals that is more difficult to oxidize than iron, and stress on the iron. The corrosion process involves oxidation and reduction, and the metal conducts electricity. Thus, electrons can move through the metal from a region where oxidation occurs to a region where reduction occurs, as in voltaic cells. Electrolysis is a method used to limit the effects of corrosion. Another common problem about batteries is its limited amount of energy or capacity, which can be measured through energy density. Energy density is the amount of energy in a system per unit of volume. The higher the energy density, the higher the energy that is stored per unit of volume. Battery manufacturing businesses conduct immense research to make larger capacity, higher energy density, and minimize the performance diminishing effects of corrosion. That is why they are costly. Additionally, elements found in batteries need to be mined, processed, and converted into high-purity chemical compounds. For further explanation of the entire video, advancement takes over the world. Just like how technology arises, leading to people's high demands for innovation in making their tasks more manageable. It inspires companies to create more different types of batteries to give a convenient and efficient way of living.